The salt of the earth. Salts can be found in abundance all over the world. The most common salt, sodium chloride, is mined from large land deposits and extracted from evaporated seawater to be used in the flavoring and preservation of food. The salt, calcium carbonate, is found in limestone and in the shells of sea animals. Another salt, potassium chloride, is found in the bodies of many animals and is a supplier of electrolytes, or electrically charged substances, needed by nerve cells. Many other salts are used to make chemicals needed for the manufacturing of industrial and agricultural products. For example, ammonium nitrate is used in fertilizers to affix nitrogen to the soil. Despite their many forms and applications, all salts share certain chemical properties. All salts are made up of ions, atoms or molecules with positive or negative charges resulting from loss or gain of an electron. Salts are generally defined as ionic compounds that do not contain hydrogen or hydroxide ions. A molecule of sodium chloride, for example, is formed by the joining of one positively charged sodium ion and one negatively charged chlorine ion. The ions of salts are held together by ionic bonds. Such bonds are formed by the electrostatic attraction between the oppositely charged atoms. Through ionic bonding, the positive and negative ions create an ordered, repeating pattern called an ionic lattice. The lattice forms a structure called a crystal. When a salt crystal dissolves in water, its ions are released from the lattice and move about freely in the solution. Chemists define salts more specifically as compounds formed by the reaction of an acid and a base. The simplest acid-base reactions are those that follow the Arrhenius definition of acids and bases. The Swedish scientist Svante Arrhenius proposed that acids are compounds that contain hydrogen. They release a positively charged hydrogen ion when dissolved in water. When hydrochloric acid is dissolved in water, for example, its molecules separate into positively charged hydrogen ions and negatively charged chlorine ions. Bases, he suggested, contain molecules of hydrogen and oxygen called hydroxides. They release hydroxides as negative ions when dissolved in water. For example, sodium hydroxide molecules break into positively charged sodium ions and negatively charged hydroxide ions in an aqueous solution. Reactions between Arrhenius acids and bases result in the formation of water and salts in a process called neutralization. Neutralization is aptly named because it has the effect of weakening or neutralizing the acidic properties of an acid and the basic properties of a base. When a hydrogen-releasing acid is mixed together with a hydroxide-releasing base, the ions of both substances react with one another. The result is the formation of new compounds. Because opposite charges attract one another, the attraction between the positively charged hydrogen ions and the negatively charged hydroxide ions results in the formation of a molecule composed of two hydrogen atoms and one oxygen atom, commonly known as water. The remaining ions in the solution react in a similar way to produce a salt. When hydrochloric acid is mixed with sodium hydroxide, for example, the negatively charged chlorine ions attract the positively charged sodium ions. The product is sodium chloride or table salt. The neutralization reaction of an Arrhenius acid and an Arrhenius base will always produce water and a salt. In the process of neutralization, salts will sometimes assume acidic or basic properties. This depends on the degree to which acids and bases are neutralized. If the acidic and basic reactants are completely neutralized, the salt produced is called a normal salt. In the case that neutralization is incomplete, however, acid salts or basic salts will form. Acid salts, such as sodium bisulfate, which is used in many household cleaners, contain hydrogen ions. Acid salts act like acids as well as salts. Basic salts, such as potassium hydroxide, which is used for making soaps, contain hydroxide ions and, in general, behave like bases. Despite the many different appearances, tastes, smells, and behaviors, all salts are composed of positively and negatively charged ions and are the products of acid-base reactions. They are often essential to the many biological and geological processes of the Earth.